Yes, we are dancing to Kahoot music today. Alright, so I gotta turn my Kahoot down. I got plenty of time. I still got 9 hours to go. Actually, even more than that. I got 9 hours and 59 minutes to go yet. Woo! So, first one. -2 is going to equal my first term plus 3 minus 1 times d. So that's going to be -2 is going to be my first term plus 2d's. Yes, Other one. 43 is going to be my first term plus 18 minus 1 times d. So that's going to be 43 equals a sub 1 plus 17d. Now, let me ask you a just observational question. Much like I'm observing people trying to snap me right now. Yeah. Okay? Is my common difference going to be positive or negative? Why? Because that's the way it is. Some things will never change, saying Bruce Hornsby in the range. Right? Why? It's going, so my third term is negative, right? And my 18th term is positive. Okay? So that's increasing, so my common difference when I find it had better be positive. Okay? That's one way. That's one observation. Okay? So, switch the signs on all of these. 43 gets me there. Gets me 45 equals 15d. So positive 3 is equal to d. Yes, sir? Because we multiplied the entire green equation by a -1.
Oh, okay.
In order to facilitate elimination.
So we have to show that we have to do like the 18 minus 3 and a half is 15d.
Make sure you get enough work that I can see what your thought process is, okay? Okay? So then, -2 is going to equal my first term plus 2 times my common difference, which was 3. So that becomes -2 is equal to my first term plus 6. -8 then is my first term. Yes, sir? Yes, sir. Okay, so now we can write our rule. A sub n is equal to -8 plus 3 times the quantity n minus 1 works for me. Or A sub n is equal to 3n minus 11. Yeah? Oh, you'll love the next slide too.
Oh, not the math part.
Oh. What's up?
So when we're finding a of 1, why was it -2 equals a of 1 instead of?
Because I put it back into the green equation.
Doesn't matter which equation.
Nope. Yes.
Oh my God.
It's hanging up on the wall. I was walking by yesterday, and we had a little volleyball volleyball practice for some 7th and 8th graders, and Nick, lady killer, on the wall. Huh? Exactly. All right. So we talked about this problem last week, Thursday. We should have talked about this problem last week, Wednesday, and then did what we were doing today on Thursday, but that's not going to happen. I'm over it. Okay? You know why I'm over it? Anyways, so a tall brick building has a decoration as shown. Each brick has a height of 1 foot. How many bricks would it take to build the decoration 15 feet? You got to run to yourself to Menards and you got to get up some bricks. Okay? We're getting closer to solving this. Okay? So, let's talk about this one. So it says from yesterday, but really it means from Thursday. Okay? So we need to find how many bricks there are in the 15th row. So, how many are there in the first row? There is uno briccato in the first row. I don't even know if that's the... Okay? Then, oops, tap the brakes. I don't want plus. I want to list it. How many are in the second row? 2. In the third row? 3. In the fourth row? 4. And so on and so forth, right? Okay? So, if I went back and I utilized my a sub n is equal to a sub 1 plus d times n minus 1, thangy thang, and I want to figure out how many bricks are in the 15th row, how many are in the first row? 1. Common difference? 1. 15th row then would be 15, right? 15 minus 1 is 14. 14 times 1 is 14 plus 1 is. So there are 15 bricks in the 15th row. Okay? Alright? Now, we can change that because that's in sequence, correct? We can make that a series because we add series. Sequences are just lists of numbers that have a pattern. Series, we add them all together. So I can add all of those numbers up. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, 9, 10, 11, 12, 13, 14, 15, right? 1 plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, 8, plus 9, 45, plus 10, 55, plus 11, plus 12, plus 13, 91, plus 14, 105, plus 15, 120. So there's 120 bricks. We got to go to Menards. We got to get 120 bricks. Okay? Cool. 120 bricks. Yeah, buddy? Yeah, buddy. Okay? Was that the easiest way to do it? Adding 15 numbers isn't that bad. But what if I said the pattern goes for 280 rows? You want to add 280 numbers? Not me. Even if I am jamming out to some Kahoot music. Okay? Alright? So there's got to be an easier way. So, because adding manually isn't always realistic. So, the summation formula, and this is only for arithmetic sequences and arithmetic series. Okay? The sum of the first n terms is equal to the number of terms divided by 2 times the quantity of of the first term plus the last. All right? So, back, whoop, temp breaks. I forgot one thing. Got to go all the way back down here now. These three things are we need to have three things, right? I need to know the total number of terms. I need to know the first term. I need to know the last term. If I don't have something, I got to find it. Okay? So, for instance, here is our series, right? 3 plus 8 plus 13 plus 18 plus ... plus 48. Right? Okay? That's kind of bugging me. Oh, now it's space. Okay. All right. Do I know my first term? Yes, it is 3. Do I know my last term? Yes, it is 48. Do I know the total number of terms? I do? But do we know it right from the start? No, don't know it, so we got to find it. So I'm going to have to find using a sub n equals my first term plus my common difference times n minus 1. And I'm going to solve that for n. So that's going to be 48 equals 3 plus what's my common difference? 5 times n minus 1. Right? Now, you could distribute, correct? Yeah? And then combine like terms, move stuff over, divide by 5. Yes? Okay? Or you could do it this way. I'm going to subtract 3. That gives me 45 equals 5 times the quantity n minus 1. Then I'm going to divide both sides by 5. That gives me 9 equals n minus 1. Then I'm going to add 1. That gives me 10 is n. Yeah, yes, sir? Okay. So now I get to go over here and I get to say the sum of the first 10 terms is equal to 10 divided by 2 times the quantity 3 plus 48. Ten divided by 2 is 5. 5 times 3 plus 48 is 51. 5 times 51 is 255 is the sum of that series. Yes? Okay. Now, since we're talking sums today, what comes into play is our old friend sigma. Okay? So refreshing your memories on the sigma. Sigma has a variable. It starts at a number. it ends at a number, and there is some kind of a rule going on with it. Yes? Okay. So, if this were my sequence, or my series, I should say, because there is we're adding them, I should say. Okay. So, sigma, I need to pick a variable. Let's do A. Okay. Does it matter? No. Okay. Where do you want to start? How about 1? Okay. If I start at 1, then this is my first term. Where would I end then? I'd end it at 6. Now I just need the rule. Okay. So A sub n is going to be my first term plus d times n minus 1. So that is going to be, I'm not going to plug in negative 24 there, but I'm going to plug in 16 here, plus what's my common difference? Negative 8. So I'm actually going to subtract that off, times n minus 1. And that would be a rule, correct? Yes? So I could put that in here. But now I got to change it to A because my variable is A. Right? I could also write this as sigma. Give me another variable. Q. Q equals 1 to Q equals 6 of, if I would go back up here, this would be negative 8n plus 24. Down here, it would be negative 8q plus 24. Yes? Okay. You try this other series now. So my rule would be 3 plus my common difference is 7. That one. Or it would be 7n minus 4. So my two sigmas would be, I'm going to go with P equals 1 to infinity of 3 plus 7 times the quantity P minus 1, or we'll go K. Oh, gotta go down a little bit. K equals 1 to infinity of 7K minus 4. Yes? Okay. Now, let's talk putting sigma into sums, because that's what sigma is all about. That's summation notation. So we have to find sums when using sigma. Well, what are the 3 things we need to find when when we are finding the sum? 3 things that I have to find. The first term. 2 other things. The last term. And the total number of terms. Okay? How do I find, using sigma notation, the first term? How do we find the first term when using sigma notation? Plug in because it's not always going to be 1. I plug the start into the rule. So that's going to be 3 times 1 plus 2. 3 times 1 is? Plus 2 is? 5. So my first term is 5. How do I find my last term? RC? So I plug the end into the rule. So that's going to be 3 times 65 plus 2. 3 times 65 is? 195 plus 2 is? 197. Now, the all-important, how do I find the total number of terms? This one's a little trickier. You might not remember it from last year. I take my end and I subtract off the start, and one more thing. And not subtract 1, add 1. End minus start plus 1. So in this case, it would be 65 minus 1 plus 1 is 65. So the sum of my first 65 terms is going to equal 65 divided by 2 times 5 plus 197. So that is 65 divided by 2 times 202, which is 65 times 101, which is 6,565. As my sum. Okay? You try that one. First term. I get 64. Last term. $952. Yep. Total number of terms. Yeah. Okay. So the sum of the first 75 terms is going to be 64 plus 952. Yeah? So that is 75 divided by 2 times, what's that? 1016? Okay. So that's really 75 times 508, which is 38,100. Yeah? What if this would have went till infinity? Could have I found it? If my end would have been infinity? Can I find the sum of an infinite arithmetic sequence or series? No. No. Because the numbers just keep growing or they keep getting smaller. Right? Okay. Uno more. Try that one. First term. First term, negative 12. Last term. $1,108. Total number of terms. So the sum of the first 281 terms is 281 divided by 2 times negative 12 plus 1,108. So that's going to be 281 divided by 2 times 1,096, which is going to be 281 times 548, which is 153,988. Yes. 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 Okay. Last one?
Yeah.
Ready for it?
Yeah.
Knock it out of the park? Yeet. The end is fun. So it's 5 problems. Okay? I would prefer it's due tomorrow, but I won't count it as late until Thursday. Okay? But it literally is 5 problems. You have 10 minutes. Could probably get it done before you leave class today. Not saying. Just saying.